All right, folks, we are going to work on the second section of chapter 7, which is going to be multiplying polynomials. Okay, we have two learning targets. One is that you can use polynomials to solve real world problems, then also that you can multiply polynomials. Okay, within today's work, we are going to just work on the notes here. I'm going to assume that you've already gone through the tile activity that we did in class, which means that you can start your notes on 7.2 notes, page 5. Okay, the product of two polynomials is always a polynomial. So like the set of integers, the set of polynomials is closed under multiplication. You can use multiple methods to multiply polynomials, such as the distribution or FOIL method. My guess is if you're getting help from home, you probably have been taught distribution or FOIL method. That's fine. Continue to use that if you understand. But in this class, we're going to utilize the box method. Okay. So this is my suggested method, but it's not the only method that you can use. If you like or know other methods, feel free to use it. Okay, box method kind of stems from the tile work activity that you should have done in class. And in this situation, what we're going to do is we're going to have x plus 2 times x plus 5. We're going to visualize a box of the algebra tile set up. So x plus 2, x plus 5. Okay, and then what we have to do is we have to multiply each part together to figure out what each quadrant represents, and then find the like terms that are together and combine them. So I have x and x times x. It's going to be x to the second power, x to the first times x to the first. Your exponent rule would be to multiply, or multiplying your exponent rule would be you add them. So even though we're multiplying, you add the exponents. Okay, x times 5 times x. X times 2 would be 2 times x. And 2 times 5, which is 10. Okay, so then now what we're going to do is we have an x squared here. We have 10 ones here. We need to find that these are alike terms. And since they're alike, you're going to add them together. So 5x and 2x is 7x. My answer is x squared plus 7x plus 10. Okay, so we're just going to work on the same method, kind of on repeat for the majority of the work. So here, same sort of thing. I have x minus 4 here. I have x squared plus 3. And we're going to find the parts, and then we're going to multiply the parts together. So I'm going to x squared times x. So x to the second times x to the first. Again, our multiplication rule of exponents is actually to add the exponents. So I have x to the third. Negative 4 times x is negative 4x squared. Negative 4 times x squared is negative 4x squared. Positive 3 times x. Positive 3x. Positive 3 times negative 4 is negative 12. Then again, you want to look for like terms. In this situation, there are none. These are not like terms because they have different exponents. Same here and same here. So my final answer is just this in standard form: x cubed minus 4x squared plus 3x minus 12. And that's at the core of the box method of multiplication. Technically, if you use the distribution method or the FOIL method, it's all the same. So again, we're okay with you using whatever method. This is just the method that we will teach here. Okay. So now I have 1C. Same setup. It's on repeat. Of 2x minus 3 times x plus 5. So here, again, you need to remember if I have 2x times x, that's 2x times 1x. So 2 times 1 is 2. X times x is x squared. Okay, 1x times negative 3, or negative 3 times x is negative 3x. 5 times 2x, 5 times 2 is 10. So this is 10x. 5 times -3 is -15. Once again, you want to check for like terms, and I do have like terms here. My 10x and my -3x are going to combine together. They're going to combine into a positive 7x. So here I get 2x squared plus 7x minus 15. Okay, 1D, same thing. The only difference in these ones is I have coefficients in front of the x terms. So I'm going to continue to do the work required of me. So 3x minus 1, 2x minus 3. 2x times 3x, 2 times 3 is 6. X times x is x squared. Okay, then I'm going to go here, -1 times 2x, -1 times 2 is -2. X times no x's will be just x. 3x times -3 is -9x. -3 times 3 is -9. X times no x's will just give me an x. And then here, -3 times -1 is +3. Again, I want to check like terms. I do have like terms here in -9x and -2x. Those numbers combine into -11x. So 6x squared minus 11x plus 3. Okay, that's the vast majority of the work we're doing today. So why don't we take a second, pause the video, and work on monitoring progress 1 through 4. When you're done, unpause the video, check it with me to ensure that that's what you're doing correctly. Okay, so I'm assuming that you've already taken the time to work through these problems. I'll fly through these best I can. So m-3 times m-7, set up a little box. The way you orient the box doesn't matter. So if I have m-3 on the top and you have m-7 on the top, it's okay. You should still get the same answer as me. So this m times m is m squared. M times -3 is -3m. M times -7 is -7m. -7 times -3 is +21. I do have like terms in -7m and -3m. -7 minus 3 is -10. So my answer is m squared minus 10m plus 21. Okay, 2, same thing. Just remember that if you set it up slightly different from mine, it's okay. You know, for the most part, I just kind of put them wherever I do. Okay, x times x would give me x squared. X times 2 would give me 2x. -4 times x would give me -4x. -4 times 2 is -8. Okay, like terms again here and here. Although it's most common for your like terms to happen in these corners, it's not a guarantee. We've actually already seen an example. 1B is an example where those are not like terms. So don't automatically combine them, but that is most frequently where the like terms will appear at. Okay, number 3. And to set it up the same way. N plus 2, n squared plus 3. N squared times n would be n to the third. N to the second times 2, 2n to the second. 3 times n is 3n. Okay, and 3 times 2 is 6. Here is a great example of exactly what I was just talking about. We don't have like terms here. I can't combine 3n and 2n squared. They're not like terms. So we just write them all out, again, in standard form. And that is a 2 there. It's poorly written, but it's a 2. Okay, and then 4. Okay, 5x times 2x, 5 times 2 is 10. X times x is x squared. 5x times -1 is -5x. 2x times -4 is -8x. -4 times -1 is +4. And this one does have like terms. It's here and here. That's going to combine into negative 13x. So my final answer is going to be 10x squared minus 13x plus 4. Okay. So now the question begs is, that's how you do a two-term by two-term. You set up a little box, a two-sided box by a two-sided box. Easy peasy. Well, what about if I have a two-term by a three-term? Well, for me, it's a pretty logical progression that if I have a 2 by 2, that's a binomial times a binomial, I have a 2 by 2 box. If I have a two-term by a three-term or a binomial times a trinomial, what do? Well, you just add another row, another column, whatever you may want it to be, and you set up a 2 by 3 box. Again, the orientation of the box doesn't matter. We're just going to multiply, make sure each part here is multiplied through. So you set up the box and then you multiply the same way that we just did on the previous page. So here, if I have x times x squared, give me x to the third. X times 2x is 2x squared. X times negative 3, negative 3x. Now I have to multiply this negative 1 through all the parts. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times negative 3 is positive 3. Okay, this one I have two sets of like terms, and it's very common for that to happen. Okay, so don't feel like you're doing it wrong. It is important to note that where the red and blue like terms combine is easily the most common place for the like terms to be, but don't take that for granted. Actually check and ensure that they are like terms. So what I have for an answer here is x to the third. 2x squared minus 1x squared would be 1x squared. Negative 3x minus 2x is negative 5x. And plus 3, nothing combines with it. And that's your answer to 2A. Okay, 2B, same setup. I have a 3 by 2, a two-term by a three-term, a binomial times a trinomial. Go ahead and multiply those parts together and utilizing the box method. Okay, go ahead and find the multiplication of each part. K times 3k squared would be 3k to the third. K times k would be k squared. K times negative 4 would be negative 4k. Okay, 7 times 3k squared would be 21k squared. 7 times k would be 7k. 7 times negative 4 would be negative 28. Okay, then what you need to do is find the terms that are alike. I have like terms here and here with my k's, and here with my k squareds. So now what I'm going to do is I'm going to combine the terms that are alike and go 3k to the third. 21k squared and 1k squared would be 22k squared. And 7k minus 4k would be 3k. And then negative 28 combines with nothing, so that's just going to be out on its own. Okay, as normal, pause the video, take a second to work on monitoring progress 5 and 6, and check it, unpause the video and check it with me when you're done. So I'm assuming that you've already taken the time to do that. Let's actually go ahead and check our answers here. Okay, a trinomial times a binomial, I'm going to set that up with the box method here. X times x is x cubed. X times negative 3x is negative 3x squared. X times 2 is 2x. 5 times x squared is 5x squared. 5 times negative 3x is negative 15x. And 5 times 2 is 10. Okay, as you've kind of seen, you got like terms in the expected positions. Feel free to combine those. So I get x cubed 5x squared minus 3x squared is 2x squared. Negative 15x plus 2x is negative 13x plus 10. So that's my answer. Make sure you write your answer in standard form. That's just the proper way to do it. It also makes your teacher's job a lot easier to grade these. Okay, last one of these before the word problems. Okay, 3 by 2. So n times n squared is n cubed. N times negative 2n is negative 2n squared. N times 4 is 4n. N squared times negative 3 is negative 3n squared. Negative 3 times negative 2n would be positive 6n. I could see that being tricky. Negative and a negative is positive. And then negative 3 times 4 is negative 12. Okay, then go ahead and find the parts that combine together. Your n's combine together and your n squareds combine together. Ultimately, you're going to get an answer of n cubed. That's negative 5n squared. This is 10n. And then minus 12. And that is my answer. Okay. Move on to the word problem. Okay, so this one, these problems are tough to recreate, so you have to know how to utilize a formula. Okay, in hockey, a goalie behind the goal line can only play the puck in this trapezoidal region, which is kind of diagrammed down here and then kind of blown up for us to see it a little bit better. Write a polynomial that represents the area of the trapezoidal region, and that's a formula for a trapezoid. Okay, typically a trapezoid is set up in a base 1, a base 2, and a height. And that's exactly what our formula has. So here, what we're going to do is say that the area is equal to 1/2 times height, x minus 7, times base 1 plus base 2. So base 1 is x, and base 2 is x plus 10. Okay, that right parentheses here, base 1 plus base 2 can be simplified. X plus x is 2x. And then these two parts multiply together. Okay, we have 3 parts that we're multiplying. My suggestion is do 2 of them first and then multiply by the third at the end. So 2x times x is 2x squared. 2x times negative 7 is negative 14x. X times 10 is 10x. And 10 times negative 7 is negative 70. I do have like terms here and here. X or 2x squared minus 4x minus 70. Okay, and then now I have a half times all that. So all you have to do is distribute a half throughout. So half times 2x squared is x squared. Half times negative 4x is negative 2x. And half times negative 70 is negative 35. So that's the answer to part A. So this represents the region, the area of this region here. If our base 1 and base 2, base 2 is 10 feet longer than base 1, and the height is 7 feet shorter than base 1. So find the area of the trapezoidal region when the shorter base is 18. So in this situation, this means base 1 is equal to 18, which means this expression x is equal to 18. Okay, so we're going to plug 18 into this formula. We're going to replace all x's with that 18, not just one of them. It says x equals 18, so all x's get replaced with 18. And then I'm going to evaluate this. I'm going to utilize PEMDAS. Inside of parentheses are already simplified. Exponents, I do have exponents. I have 18 to the second power, so I'm going to utilize a calculator for that. 18 to the second power is 18 times 18, 324. Okay, so that's all my exponents. Multiplication and division together. I do have multiplication right here. Okay, 2 times 18 is 36. And then addition and subtraction, I have a bunch of subtraction, so I'm just going to do that all in a row. So my area is going to be equal to 253 feet squared. So make sure you're labeling correctly. If it's a straight line distance, it's going to be feet or inches or whatever. If it's an area, it's feet squared. And if it's a volume, it's feet cubed or meters cubed or whatever it may be. Okay. So here's my suggestion to you is utilize the formula that's going to be given to you. And then find those parts within that and then utilize the formula. And it's probably going to utilize some multiplication as this is the multiplication section. So let's move on to monitoring progress number 7. I'm going to give you a hint here. One area of a rectangle is length times width. And the second is, if I want to find this width here, I would just add all these parts up. So it'd be x plus 20 plus x. So this width is 2x plus 20. Okay, so you would have to do the same thing on the bottom to find the length. All right, so I'm going to let you pause the video and go ahead and try monitoring progress number 7. And then when you're done with that, unpause it and check it with me. So like I said, I'm assuming that you've already done that, the work, and you're just here to see how you did. So what we're going to do is we have already had solidified that the width is going to be 2x plus 20 because you have 2 x's and then a length of 20. This one's the same thing. I have 2 x's and a length of 22. So this is going to be 2x plus 22. So part A says that my area is going to be length times width. Well, my length is going to be 2x plus 22. And my width is going to be 2x plus 20. So I have to multiply this. And again, in this class, we utilize the box method. If you want to use a different method, that's by all means, you have that right. So 2x times 2x, 2 times 2 is 4. X times x is x squared. Okay, what about 2x times 22? So 22 times 2 is 44, so this is 44x. 2x times 20 would be 40x. And 20 times 22 should be 440. I'm double checking it. It is. I have like terms here and here. So my area is 4x squared plus 84x plus 440. That's the answer to part A. Part B says find the combined area of the photo of the frame when the width of the frame is 4 inches. So it's not saying that this whole thing is 4 inches. It's saying that this width here is 4 inches. So that means our x is going to be equal to 4. And then we can just plug that value in. So I have 4 times 4 squared plus 84 times 4 plus 440. Okay, we are going to utilize PEMDAS to evaluate this. Okay, P is going to stand for parentheses, none to do. E for exponent. I do have one exponent here, 4 squared, so that's going to be 16. Multiplication and division, left to right, I have 2 instances of that. I have 4 times 16. So 4 times 16 is 64. I should have known that. 84 times 4, so 84 times 4, 336. And then here I have to work through addition and subtraction. I have a bunch of additions, so 64 plus 336 plus 440 going to be equal to 840. And what's the label? I'm working in inches, but I'm talking about the area, so it would be inches squared. Okay. Let's figure out what our practice problems are, and I will let you go. Okay, so your practice problems are going to be problems 11 through 18. Go ahead and pick 2 of those. 35 through 42, you can pick 2 of those. And lastly, number 43. Okay. So there's your practice problems for your learning targets. Go ahead and work on those. Otherwise, I will see you next time.